Hello everyone, thank you for having me today. Please let me introduce myself. My name is Dwipaningtyas, but you can call me Tias. I'm from Exploration Division at PT Pertamina FA. Today I will talk about reservoir fluid analysis using extended elastic impedance inversion in Basin for fan middle Baong sand at Aru area North Sumatra Basin. And before starting my presentation, it is important to say how can the essential fluid analysis or fluid detecting as one part of oil and gas prospect identification. Imagine, what if you found a thick, perfect reservoir, but you doesn't get any hydrocarbon accumulation? It will be disappointed, right? So, fluid detection or fluid analysis is a hint to estimate where hydrocarbon accumulation for a bridging to the next study for trap and migration evaluation. And in this study, I use extended elastic impedance or EI to predict it. Yeah, so let's get started. This is my profile. My educational background is geophysical engineering at IITB, and I started my career at PT Pertamina FA since 2014 until now. Okay, this is my outline presentation. Today I will talk about introduction. It is regional geology, background, and objective of study, and elastic impedance and inversion basic theory, and talking about data availability, workflow, and the method, and result and discussion of study. And the last is conclusion and recommendation. Okay, this is my background of study. This is Erada well. Erada well is an exploration well that was drilled in early 2019. The location in the western part of Aru area. Erada well have a low angle monocline structure and have stratigraphic and structural trap. In Aru area itself, in North Sumatra Basin, is known for its mature fields, such as in here, PTB field, BSF field, and SHF field. And the prolific hydrocarbon producer in this area is come from the Basin River Sand, as a member middle Baong sand. Okay, this well, Erada well, discovered 60 meters of the Basin River Sand with good porosity is around 15%, but have a low resistivity is around 3 until 4 ohm. But the average resistivity in the bare S zone in the surrounding field is around 10 ohm. And unfortunately, in this zone, the layer shows a small gas unit. And moreover, gradient pressure analysis and fluid tester reveal that this Basin River zone is a wet reservoir sand. So, fluid analysis in Aru area is used to get a lesson learned from Erada well. EI inversion is used for detect hydrocarbon anomaly, which utilize elastic parameter. Okay, this is introduction, regional geology, and main objective. Aru area is known as a mature field, and the first wildcat, Telaga Said, was drilled here. And the prolific hydrocarbon producer is come from Basin River Sand as a member of middle Baong sand. The Baong formation itself can be differentiated as a 3 parts. They are upper Baong shell, middle Baong sand, and lower Baong. The sedimentation filling began in Oligocene until early Miocene with the transgressive sequence of Parapat, Bampo, and Belumai formation. And the subsidence continued until mid-Miocene, where lower Baong shell was deposited. And in the end of mid-Miocene, Bukit Barisan uplifted, and middle Baong sand deposition was started by a turbided wave as a basin flow fan or submarine fan in the deep water environment. Okay, this theory of EI and seismic inversion. seismic inversion is being used to estimate impedance profile in subsurvey by reduce discrepancies between observed and model data. And for a simple example from seismic inversion is acoustic impedance inversion that have main objective to extract underlying geology from post-text seismic data. And then elastic impedance, or EI, is a generalization of acoustic impedance for variation incident angle. EI can be expressed as a simple function of primary velocity, shear velocity, and density, which is stated as A-intercept or B gradient and angle for the theta. Unfortunately, this equation EI has a strength unit. So this EI limitation was overcome by EI or extended elastic impedance by extended the angle range and substitute the sin quadrat theta by the tan chi. So this equation has a normal unit. The variable chi varies between -90 to 90 degree, and chi angle can be selected to optimize the correlation curve of EI with a specific elastic parameter. Okay, this is the workflow and the data availability. In this study, 3D seismic is used in angle partial stack data to generate intercept volume and gradient volume. And for well data, since in this 3D seismic area, RAD well is the only one well that have shear velocity data. So triangle scanning only performed in this well. Meanwhile, the well data required are PP, VS, and density. And then this reflectivity volume will generated from intercept volume, gradient volume, and chi angle. And then we get a reflect extraction to well seismic type, and we build the model based on horizon interpretation. And then the reflective volume will be inverted by model-based inversion as a VP per PS ratio volume. Okay, this result and discussion in RAD well, we can see in here based on rock physics template or RPT, which is a cross plot between acoustic impedance or the slowness versus VP-VS ratio. In here, in Basin reverse sand interval, you can see on RAD well is a consolidated sediment with porosity is around 15%, and the value of VP-VS ratio is 1.6 until 1.8, which can be defined as between less gas saturated and mostly water saturation sand. This G parameter scanning is used to see which elastic parameter. This is some elastic parameter that will have high correlation with a certain chi angle. In this study, chi angle which have good correlation is VP-VS ratio. You can see from this green curve with correlation is 1.97 and chi angle is 70 degrees. In addition, the VP-VS ratio is a sensitive parameter to see fluid anomaly in the subsurface. And to see whether scanning result is valid or not, the correlation value for the acoustic impedance parameters in this frequency is in the this blue curve. The correlation must be 1 at the 0 offset or 0 degree. Okay, this is the result of EI in the VP-VS ratio section or the volume. Here is RAD well, VP per VS ratio. This is inline and this cross line. The EI inversion give us a fairly good correlation with wells. You can see here there is a good continuity between the VPVS in the well and the section inverted. The VPVS ratio at RAD well are around 1.6 until 1.8. Okay, this based on previous study about sedimentary facies and sequence stratigraphic from borehole image of RAD well. This classified as low stand systematic deposit. Whereas interval at RAD well interpreted as a staking basin complex deposit or submarine. The sand body thickness at Basitang River sand in surrounding field is about 50 until 150 meters. Thereby, it can be easily seen in the seismic section and have a good correlation with acoustic impedance section. Based on horizon slicing at acoustic impedance inversion volume, basin floor flare deposit is mainly toward east until northeast, and the provenance is from Bukit Barisan on the west direction. Okay, this is the result of EI. We generate VPVS map. We can see in here the map gives us a fairly good result. We can see this is a horizon slicing at VPVS volume at the top Basitang River sand. We can see the spread hydrocarbon anomaly is exists inside the sedimentary facies of basin floor fan. The result shows hydrocarbon anomaly in red to yellow color, this that represented as a low VPVS ratio and has matched valid in some fields like PTB field, BSF field, TKM field, PTT field, and SHA field. And fortunately, there is a still potential hydrocarbon anomaly that needs to be explored in the eastern part. This it is marked with a dashed red boundary polygon. Okay, this is for summary. The conclusion is fluid analysis is needed as a lesson learned from RAD well. Extended elastic inversion is used to solve this problem. VPVS ratio is one of elastic parameters to see fluid characteristics, and in east of our area, which have hydrocarbon anomaly that represent as a low VPVS ratio. And for next recommendation, next study, trap and migration pathways evaluation is must be required, especially in this sweet spot area, to mitigate the no trap hydrocarbon in this structure. Okay, this for closing, I quote I take a quote from George E.P. Box that all models are wrong, but some are useful. I hope this study get inspired us how to detect hydrocarbon anomaly with the maximum data that we have. Maybe my model is not completely true, but I hope it is useful to lead us to get a new discovery. Thank you for your attention.